From this section, we are going to start the part design module of Catia. We are going to make solid models. Let us open a new file. I'll go to File, New. Here we'll select Part and click on OK. Here also click on OK. We are in the part design interface of a new file. Now in the earlier videos, that is in the Sketcher module, we were creating a sketch. For a solid model, the base is a sketch. Let us create a rectangle. I'll click on the sketch icon, select on this plane. Let us create a rectangle. Now to exit from the Sketcher interface, you have to click this icon, Exit Workbench. Click on it and you can see we are outside the Sketcher interface and inside the part design interface. We are moving around in 3D. I am rotating. For rotating, click on the scroll of the mouse and the right click. Press and keep both the buttons and move the mouse. You can rotate the view. Let us create a solid. For creating a solid, there is a tool called Pad. Click on Insert, Sketch Based Features. As the name indicates, we require a sketch for creating this feature. The very first command is Pad. Click on Pad. Now let us select the sketch. Something is happening. Just click on OK. We have created a solid. You can see this is a solid from the base sketch, which is a rectangle. So we have just added a height to the sketch. Let us double click again on this solid. You can see here, this is the height that we can give. If you increase this, you can see the height of the solid is increasing. But the base is a sketch. Click on OK and you can see we have made a solid. In the next video, we are going to see the Pad tool in details. In this video, we are going to see Pad and Pocket. We are going to see just an introduction to Pad and Pocket. Later on, we will see Pad and Pocket in details. Let us create a rectangle first. Click on the Sketch tool and let us create a rectangle. Here, we'll use Exit Workbench. Click on Exit Workbench to get into the Part Design module. Here, we will have the tool Insert, Sketch-Based Features and Pad. This tool you will get it here. This is the Sketch-Based Features toolbar. You can use this toolbar. Click on this first icon, which is Pad. Select the sketch and here you can give the length value. You can see we can increase the length, and if you use this preview, you can see the solid. If you want to edit the base sketch, you can also click on this icon. Click here. If you want to change, I can maybe delete this and maybe I can attach a few lines. Something like this. Press on the escape key to exit from the command. Now click here to exit Workbench. Click on OK and you can see when we change the sketch, automatically the pad changes. Now let us create a sketch on this face. You can see till now we were selecting only the planes. We can also select face. Select the face and select sketch. Now we are on the top plane of this solid. You can see this V and H is on the top plane. We'll select this normal view. Now let us create a rectangle, maybe here, and finish the sketch. We want to cut this solid by using this rectangle. For that, I'll take Insert, Sketch Based Features. We'll have the second icon, which is Pocket. Click on Pocket. Select the sketch. You can see here something is happening. I will reduce this value. Click on OK. And you can see we have removed the material. So, Pad will add material to a sketch and Pocket will remove material from a sketch. Pocket requires a minimum of one solid body, because if a solid body is present, then only we can cut it. So you might be seeing here, when we didn't have a solid body, this pocket and some features were de-highlighted. Let us see it again. I'll undo. Click on the Ctrl+Z key to undo. Now we don't have any solid body. Select Insert, Sketch Based Features. You can see few options are de-highlighted because they cannot be used now as there is no solid body. So we have to create a solid body. So the options which are available for creating a solid body are highlighted. In the next video, we are going to see an example using this Pad and Pocket. Also, after few videos, we are going to see Pad and Pocket in details. In this video, we are going to make the 3D model of example 19 drawing attached with this lecture. As you can see here, this is the example 19 drawing that we are going to make. This is the 3D model with the dimensions, and this is the 2D drawing. Let us start. When we open Catia, you can see it is opening the product interface of a new file. We don't want it. So I'll go to File and close this. Again, I'll go to File, New, and I'll select Part. Click on OK. Click on OK here. Now we have opened a new file in the Part Design interface. Let us first create a sketch. I'll click on Sketch, select this base plane. I'll make a rectangle. Select on the rectangle tool and the first point take as the origin. Now create the second point and let us give the dimension. Double click on dimensioning. This dimension is 80 and this dimension is 100. I am creating the base rectangle. You can see I have created the base rectangle. Now click on Pad and select the sketch. Give a dimension of 60. Now let us select this plane. Click on Sketch and select this plane. Let us create the stepped portion. We'll create a rough profile sketch. We'll create a step portion, a vertical and a horizontal combination of lines, and I'll join. Now let us constrain it. First, I'll take this line and this edge. We'll go for coincidence. Again, this line and this edge. Coincidence. Double click on dimensioning. Let us give the dimensions. This dimension is 25. This dimension is also 25. And this dimension is also 25. Double click, 25. Now, this dimension is 15. This dimension is 15. Now only this dimension is remaining. This also is 15. You can see the sketch is fully constrained. Exit the workbench. Now select pocket. If you want to add material, the tool is pad. If you want to subtract material, the tool is pocket. Select the sketch and give a dimension. The dimension is 60. Click on preview. You can see there is a preview of the thing that is going to be made. Click on OK. And we have made the required 3D model of the drawing attached with this lecture. In this video, we are going to see the pad tool in details. Let us create a sketch. Select this plane. Click on sketch and let us create a rectangle. Exit Workbench. Now click on pad and select the sketch. You can see here limit 1 and limit 2. These two options are for giving dimension to the pad. Normally when you click here and give a value of 50, it gives a thickness of 50 from the base plane. That is the sketch plane. Double click on the solid to display the pad definition dialog box, which we have used to create this pad. And let us modify it. Click on more. Here you will have the second limit, first limit and second limit. You can give a value to the second limit. You can see when I increase the value, solid is getting formed on the other side also. Click on preview and you can see this is the sketch plane and material is adding on both the sides, the value of which is defined by the first limit and second limit. If I give a negative value, suppose -10, and click somewhere to get a preview, click here. So this is how we can control the pad limits. Let us give a value 0 here. Let us click preview. Here when you click the drop down, you can see there are various other things that we can use for creating a pad. We will see this in the examples. Next is mirror extend. When you click on mirror extend, you can see what happens. Both the sides 50 mm of pad will be formed. So from the center plane, which is the sketch plane, 50 mm material is adding on the top side and the bottom side. Click on preview and you can see. So this is the use of mirror extend. Click off mirror extend, click on preview. Suppose we want to create this pad on the opposite side. Click on reverse direction and click on preview. You can see here the direction has changed. Again we'll go for reverse direction. Click on preview. So this is the use of reverse direction. Click on thick and give a thickness value. Let it be 10 mm. Click on preview. You can see we are forming a thickened body. That is, we are giving a thickness to the sketch. Here we can give a thickness 2 value. Let it be some 5 mm. You can see here 10 mm is getting formed inside and 5 mm thickness is given on the outside to the sketch. When I click on preview, you can see here this is the solid that we can make by using this thickness. Here there is a neutral fiber option. When you click, you can give a total thickness to this edge. Click on preview. 10 mm is applied by keeping the sketch in the middle and dividing the 10 mm on the both sides. That is 5 mm this side and 5 mm on the other side. Click on thick again. To switch off, click on preview. Now, the next option that I am going to show in this window is very important. It is normal to profile. Let us cancel and let us undo. Press the Ctrl+Z key on the keyboard. Now take sketch again and we'll take this plane. Let us make a line in any direction. We'll take pad, select the sketch, give a value here, maybe 100. Click on more. Here, instead of normal profile which is default, if you select here and click on this line, you can see the direction is oriented about the selected line. So this is how we can create angular holes and any objects that we want to create at an alignment with another axis or another line. By default, it will be normal to profile. You can select here normal to profile. This is the default, that is normal to the sketch that we have created. When you select this and select any line which will define a direction, the material will flow in that direction. Now let us click preview and we have created a solid aligned with the line that we have selected. So this is all about pad tool. In this video, we are going to see pocket tool in details. You can see here, we have created a block by extruding a rectangle and we have created a rectangle on the top face of the solid. Now click on pocket tool and select the sketch. When I click on preview, of course it will create a pocket something like this. Let us give a depth of 50. Click on enter and it will create a pocket of 50 mm depth. Double click inside to access the pocket definition dialog box. When you click on more, like in pad, you will get limit here, first limit and second limit, which is defined by these two. You can see this is limit 2 and this is limit 1. If you want to start the cut at a distance from the sketch plane, you can use this limit 2. Click on preview. You can see it is cutting inside. So if you require this kind of a feature to be created, you can do by using this first and second limit. Let us give a value 0 here. When you click somewhere, then only this orange preview will be shown. Also, you can click on preview to get a real preview. Here also you will get a thickness. Give a value, maybe 10. You can see something is happening. When you click on preview, a thickness is applied to the sketch and material is remaining inside and only 10 mm is getting cut. So this is the importance of thick in pocket. You have a thickness 2 value here. Let us give some 5 mm. When you click somewhere, then only this preview will highlight. Click on preview and you can see from the sketch 5 mm this side is cut and 10 mm inside is cut. So this is the importance of thickness. If you go for reverse direction, outside is getting cut, but there is no material, so it will give an error. If I preview, of course it will give an error. Click on OK and reverse the direction. So if you have created a sketch in the middle somewhere on the solid, then you can use this reverse direction to cut above or below. But in our case now, we have created in the top plane, so there is no material up. We cannot cut anything on the upward direction. Click on preview and this is thickness and reverse direction. click off this thickness, click on preview, mirrored extent, you can see both sides it is getting cut. When you click on preview, it's the same because there is no material upwards. So if you have created a sketch on the center of the solid and you want to cut throughout, then you can use this mirrored extent. A very important option that I would like to show you is, here you can see it is cutting up to some depth. Suppose we want to cut throughout the body. We don't know the length of the body. We want to cut throughout the body. Then you can use here up to last. See preview. So it will cut the body up to last, whatever is the length. This is very beneficial if you create holes by using a circle and using the pocket. You just have to select the circle for a pocket and click here up to last. Automatically it will cut the entire body. Now let us cancel this and delete this pocket. Here it will ask for delete aggregate elements. Aggregated element is the sketch that is associated with this pocket. I don't want to delete that, so I will switch this off and click on OK so that the sketch will remain. Now I'll take maybe this face and create a line at an angle. Exit Workbench. Now we'll take pocket, select this sketch, go to more. Here it is normal to profile. So normal about the sketch plane, the pocket will form. When you select here and select this line, you can see the pocket is forming at an angle. The angle is defined by this line. So the pocket is aligning with this line and getting generated. You can see. Click on OK. We have a pocket at an angle. This is very important if you want to go for angular holes. Let us create it. Double click on this pocket. If you want to change the sketch, you can click here. It will take you to the sketch which is defining this pocket. Select the lines and let us delete it. And let us make a circle. Exit. Click on OK. Automatically the sketch has changed, which is defining the pocket. And an angular hole has been created, the angle of which has been defined by this line. So this is all about pocket. We'll see the application of these in the later videos. In this lecture, we are going to create the 3D model of example 20 drawing attached with this lecture. You can see this is the drawing for which we are going to make the 3D model, and this is the 3D model that we are going to make. Click on the isometric view. Now let us close this file. Click on File, New. Click on Part, OK, and OK again. So we are now in the part design interface of a new file. Let us start by first creating a sketch which will define the first base solid. I'll take sketch and select this plane. Let us create a rough sketch. I'll take profile and create a profile, something like this, at an angle, a horizontal line. I'll drag this origin and join. Let us constrain it. Double click on dimensioning. This dimension is 40. This dimension is 150. This dimension is 50 plus 30. 50 plus 30. Now from this line to this point, this value is 30 plus 50. The sketch is fully constrained. Now exit sketch. We'll take pad, select the sketch, reverse direction and give a value of 100. We have created the base solid. Now we'll take this top plane, select sketch, this top plane, and let us create the rectangles that will define the cuts that it is required on this solid. I'll take rectangle here and directly take this origin. Create a rectangle. Now double click on dimensioning. Select this line, double click, give a value of 50. And select this line, double click, 30. Exit Workbench. We'll take pocket, select this sketch, and here we'll give a value of 30. Press on enter and it will be cut. Again we'll take sketch, this top plane, make a rectangle here, select this line and this edge, coincidence. Again this line and this edge, coincidence. Double click on dimensioning, double click on this dimension and give a value of 30 and give a length to this line of 40. Exit Workbench. Now we'll take pocket, select this sketch. You can see here we want to cut to the last, so I'll select here up to last. It has cut up to last. Click on OK and you can see we have created the model. Click on isometric view and this is the model that we required to make. Now let us save this file so that we can use this file for discussing Part Navigator in the next video. I'll go to File, Save As. In the desktop, I'll give a name Example 20 and click on Save. So we have saved this file in our desktop. We'll open this file in the next video and discuss about Part Navigator. In this video, we are going to see how to show and hide object. Let us open the saved example 20 file from the desktop. I'll take file, open example 20, which is stored in the desktop. Click on open. This is the example 20 file. When you click on Part Navigator, you can see the sketch are hidden. We cannot see the sketch here, which are defining this solid. They are hidden. You can show them by just right clicking and click on hide and show. You can see this is being shown. It was hidden. Now it is being shown. So when you create a feature by using a sketch, it may be pad or pocket, automatically Catia is hiding the sketch. If you want to see the sketch, you can go for showing the sketch. Here this icon and this icon are used for hiding and showing objects. Let us click on this icon, which is swap visible space. Click on it and you can see another visible space has been shown, which is containing all the hidden elements. There are 3 sketches that is defining the solid. When you click again, this is one sketch which we have shown and these 2 sketches are hidden. Suppose I want to unhide this sketch. Simply click on show and hide. Select this. It will be hidden in this visible space. When you click on this swap visible space, it will be shown in this visible space. You can also do that for this solid model. Click on this solid model and hide it. When you click this swap visual space, it will be shown in this visible space. So there are two spaces. One is the visible space, another is the hidden space. This is the hidden space and this is the visible space. So if you hide something here, it will be shown here. If you hide something here, it will be shown here. Now I'll take hide and show, select this object and click on swap visible space. You can see this is the 3D model. So this is show and hide. Whichever elements you feel has to be hidden, you can just hide it by using this tool. In this lecture, we are going to create the 3D model of example 21 drawing attached with this lecture. You can see this is the drawing for which we are going to generate the 3D model. When you see any 3D model, you have to decide which base sketch you have to create so that it will define the base solid. And after that, on the base solid, you will select the planes and the features and you can generate the sketch and use the pocket or other tools. When you analyze this body, you can take this 150 into 100 rectangle in the base and use pad to create a 80 mm height solid body. It will be a cuboid block. And then you can create this step portion as a sketch and cut it by using the pocket. Then you can create this triangle and cut it by using pocket. But what we can do is directly I can create this sketch. This entire sketch, that is this face, we are going to create in this vertical plane and use pad to a value of 100 to create this solid. Only we will remain with this, which we can create it very easily. So it is very important for you to analyze which is the base sketch that you are going to create. That will define the complexity of your model making process. Let us start. I'll take sketch and I'll take this plane. Let us create a profile. Click on profile. Let us select origin. Make a horizontal line. Then a vertical line. Then another horizontal line. Vertical. Horizontal, vertical. I can create this constraint, which is coincidence. When this tracking line comes, you can click. Automatically the coincidence symbol will be appearing, which we require. From now on, use this power of auto constraints to create your sketch easily. You can see I have created the sketch. Now double click on dimensioning. Let us give a dimension to this. Double click 80. And this is a value 25. This is 20. Double click 20. Take this length 20. Now this is also 20 and this length is 20. Now we are left out with only this line. Double click 150. Finish the sketch. Use pad. Select the sketch. We'll use mirror extend and we will give half of the total value that we require. 100 divided by 2. Enter. You can see it has been created symmetric about the plane. Now we'll take sketch this face and create the triangle. Now we'll take this line and this edge. Coincidence. Now we'll take this point and vertical. Coincidence. We'll take this line and this axis. Symmetry. Now we'll give the dimensions. From this edge to this point, this value is 25. Now from this top to this point, this is a value 45. Exit Workbench. We'll take pocket, select the sketch and give a value. This is 50 and this is the 3D model that we wanted to make. In this video, we are going to create the 3D model of example 22 drawing attached with this lecture. You can see here, this is the drawing for which we are going to generate the 3D model. And this is the 3D model that we want to create. Let us close this file and let us open a new file. Click on New, Part, click on OK and OK again. Now we are in the part design interface of a new file. Let us start. First, let us take Sketch tool and select this plane. Let us create a rough sketch. I'll take Profile and create a sketch something like this. I'll drag this origin so that we can create a coincidence constraint. Now let us constrain it. Double click on dimensioning. This length is 20 and this total length is 80. This length is 30 and this total line length is 150. Exit Workbench. Now let us click on Pad, select the sketch. We'll use Mirror Extend. You can see what Mirror Extend will do is it will add equal material on both the side of the sketch plane. So we can give a value of 100 divided by 2 here and click on Preview. You can see per side 50 is generated. Click on OK to create the base solid model. Now we'll use the solid model and create the other sketches. Let us first select the sketch and select this plane. I'll take a circle, select this origin, select dimensioning. Let us give a radius of value 50. Exit Workbench. Now select Pocket and select the sketch. Give a value of 15. See the preview. Click on OK. You can see here the feature has been generated. Now we'll take the base, select here, make a rectangle. I'll take this line and this edge. Coincidence. Length of this rectangle here is 15 and this is of value 40. If you are not able to understand, where you should give the dimensions, you can always rotate and see where your sketch is. Now I'll take dimensioning from this edge to this line. The dimension is given as 30. The sketch is fully constrained. I can exit Workbench. Now I can take pocket, select this sketch, and here we can give a value up to last. It will cut up to last. Now we'll take this center plane, which is exactly at the center of the solid, as we have used mirror extent in pad. Now we'll take the sketch and create a triangle. Now take this edge and this edge. Coincidence. Now double click on dimensioning. This length is 30. Dimension from this edge to this line is 20. The sketch is constrained. Now exit Workbench. Use pad. We'll use mirror extent and give a value of 50 divided by 2. Click on preview and then click on OK. You can see. Now we'll take sketch on this plane and create a circle. We'll take the center of this circle and this vertical. Coincidence. Now let us give the dimensions from this edge to this center. Double click. This value is 30 and the dimension of this circle is 10 mm radius. Let us exit Workbench. Click on pocket up to last. You can select here up to last. Click on OK. You can see we have created a hole. Now we'll take sketch again and we'll take this plane, create a rectangle. We'll take this and this about this vertical. This is symmetric. Now double click on dimensioning from this edge to this line. This is of value 35. Now exit Workbench. Need not constrain the length of the rectangle because it is not going to be used. Now I'll use pocket, select this sketch. Here, if you give dimension maybe 10, get preview, you can see it is cutting up to 10 mm. In the drawing it has been given 20 mm. So instead of using 20 mm here, I'll use the option called up to plane and select a limit. We can select up to this plane. Click on preview, click on OK. You can see here, without any value, we have directly created the pocket up to this plane. This is the 3D model that we wanted to make. Click on the isometric view. In this video, we are going to create the 3D model of example 23 drawing attached with this lecture. You can see this is the drawing for which we are going to generate the 3D model, and this is the 3D model. So this 3D model we are going to make in this video. Let us go to File and close this file. Go to File, New. Let us open a part. Click on OK and again click on OK. We are now in the part design interface of a new file. Let us start by first creating a sketch. We'll take this plane, click on Profile, we'll click on this origin, a horizontal line, a vertical, another horizontal, vertical, and join. Let us double click on dimensioning. This is a value 20. Its total length is of 150 from here to here. This is a value 25 plus 55, and this line is of length 50. That is, we are going to make a circle here of 50 diameters. I'll take circle. I'll create a circle without any constraints interfering. Take this point and this edge. Coincidence. Now this circle and this tangency. Again this circle and this tangency. We'll take quick trim and trim this portion. We'll take this line and convert into reference. So this becomes a construction element. In the same drawing, if we make a elongated hole here, and when we use pad, automatically it will be a pocket. Let us try it. I'll go to Insert, Profile, Predefined Profile, Elongated Hole. Select this center point and create a spine. And define a elongated hole. Of course, as this is on, so whatever you create will become a construction element. So let us select this and click on this to create it solid. Now I'll take dimension of this spine. This is 55, and this value, which is the radius, is of 10. Let us exit the workbench. We have created this kind of a sketch. Now let us click on pad. We'll take mirror extent and give a length value of 100 divided by 2, 50 per side. Click on preview. Click on OK. You can see directly the pocket has been formed. So we need not take two sketch, one for the pad, another for the pocket. We can use this feature whenever we have some pockets to be created directly on the solid body. Now let us create the two stiffeners. For that, I'll take sketch and take this middle plane. You can see I am in the center plane. Click on normal view to get a normal view of our sketch plane. Now I'll create a triangle, a vertical line, a horizontal line, and join. Now we'll take line and this edge. Coincidence. Line and edge. Coincidence. Double click on dimensioning. This height is 45. From this edge to this point, this is a value 10. We have fully constrained it. Now exit workbench. You can see here we have a sketch in the middle. Now we want to create the stiffeners. I'll take pad, select this sketch. We'll reverse the direction. Now let us change the limits. Click on more. We have to give this start and end value, which is the first limit and second limit. We will start from 20 mm from the sketch plane. I'll give here -20 and click here to generate a preview of the orange lines. And we will end at 20 plus thickness of the stiffener, which is 15. 20 mm plus 15. We'll click here. You can see it is 35 and we have created the stiffener. If you have any doubt, you can also check these dimensions, which are the first limit and second limit. It is starting from -20, ending at 35. So this thickness is 15. So this is how we will do the calculation. Click on OK. And you can see we have generated one stiffener. Now for the other stiffener, we'll go to the part navigator. This sketch we want to use. We will unhide this sketch. Select the sketch and unhide. You can see this sketch we want to use. Again we will take pad, select the sketch. We'll click on more and we'll do the same thing. It will start at -20 and at 35 in this direction. So no need to reverse the direction. Click on OK. And you can see we have made the model of example 23 drawing. Click on the isometric view to see isometric view of the model. In this video, we are going to see how to create holes using the hole tool in Catia. Here I am having a solid block which I have created by using a pad to a rectangle sketch. We have the hole option here. Click on hole. Select the face on which you want to create the hole. You can give the diameter. Maybe I'll give 30. Click on any other option to get a preview. Now next I'll go for depth. Maybe I'll give 50 as the depth. You can see here. I'll go for OK. You can see we have created a hole directly, which we would have created by using a circle and using pocket. Let us double click on the hole. We have not positioned the hole. Suppose I want the hole somewhere here. Maybe some 20 mm from here and some 30 mm from this side. I can do that by using this position sketch. Click on this icon. Now I am inside the sketch. I'll take dimensioning from this edge to this point. I'll give a value of maybe some 30. And from here to this hole, I'll give a value of 40. Click on Exit Workbench. And you can see the hole has been positioned. Click on OK. You can see here. Directly we have generated a hole. Double click on the hole again. Here we have flat and V bottom. Click on V bottom. You can see here a 120-degree V has been generated. This feature is something like you have used a drill for making this hole. If I take flat again, you can see it is removing. Again I'll use V bottom. Click on preview. And you can see the inside surface. It's a V. You can control the angle of the V here. It's 120 degrees. You can also give 118 degrees, which are the standard angles for any drill. Click on OK. And you can see we have generated the hole. I'll select and delete it. Click on OK. I'll click on this face and create a sketch. Maybe a line something like this at an angle. Again I'll take hole. You can click here or you can also take insert, sketch based features, hole. Click on this face. Here you can give a direction to it. Switch off this normal to surface and select this line. You can see we are making a hole at an angle. Click on OK. You can see the hole is now at an angle. You can change the shading to view the hidden lines inside the body. Select here. You can see this is shading with edges, which is the current display settings. Shading with edges without smooth edges. You can see this is for hidden edges. The hidden feature is shown now. Now double click again in the hole. Here we'll take normal to surface. Click on preview. This hole we have created by using this blind option here. This is the blind hole, that is up to some depth. If you don't want to give depth, instead you want to use some extension features like up to next, last, plane and surface, you can select here. These options we'll see in the further examples. I'll take type now. This is a simple hole. If you want to create a tapered hole, you can do that by giving an angle here. Suppose I'll give some 10-degree angle. From bottom or from top, I'll give a value from top. Click on preview. You can see we have generated a tapered hole. Next is counter board. The counter board dia maybe some 50 and depth 20. You can see here it's taking at middle. We'll take extreme so that it enters inside. Click on preview. You can see this is a counter bore. Counter sunk hole will give a depth and an angle maybe 10 degrees. Click on preview. This angle will change to 45 degrees. Click on preview. And you can see this is a countersink hole. Counter drilled. The upper dia is 50, depth is 20 and the counter drill hole angle is 45 degrees. Click on preview. So this is how we can create holes. We will see this thread definition when we discuss about threads. In this lecture, we are going to see how to create multi-pad and multi-pocket objects. Let us first create a sketch. I'll take sketch, select this plane, double click on rectangle. Let us create some rectangles and maybe some circles. Now exit Workbench. You can see we have created many rectangles and circles. If I use pad, select a sketch, it will select all the sketch. When I click on OK, it will give equal height to all sketches and create solid body. Suppose we want to give different heights to different sketch. I'll use the Ctrl+Z key to undo. Now I'll go to Insert, Sketch-Based Features, Multi-Pad. Click here or you can also click here. This is Multi-Pad. Click on Multi-Pad. Now select the sketch. It will give a definition dialog box something like this. Here you can select the particular object and give a height. The object in blue is active. You can give a length. Maybe I'll give some 20 to this. Now select another profile. Maybe I'll give some 50. Another profile. Some 30. And so on. You can just select the profile and give a value. You can see all have been given different heights. When I click on OK, you can see here. Let's go to sketch. This will create some profile. Here, here. I'll create this. Here is here. If you want, when you click on OK, pad, same heights. I'll use the Ctrl plus Z key. We can use multi-pocket. You'll get the option here, multi-pocket, or you'll also get it in Insert, Sketch-based features and multi-pocket. Click on multi-pocket, select the sketch. Similar to multi-pad, you just have to select the profile and give a value, maybe 10, 20. You can see the blue color indicates it is active. Some 50. For this, I'll give some 100, and this give some 10. You can see all have been given different heights. When I click on OK, you can see each one of them have been given a different pocket values. So this is all about multi-pad and multi-pocket. In this lecture, we are going to create the 3D model of example 22 drawing attached with this lecture. You can see here, this is the example 24 drawing for which we are going to make the 3D model, and this is the 3D model that we are going to make. We'll go to File and close this file. Go to File, New, and open a new file. New part, click on OK and OK again. Let us start. Let us first create a sketch. On this plane, we will create two circles. First circle here, another circle somewhere here. Press the escape key to exit from the command, or you can also click on the circle icon. Now let us constrain them. We'll take this center and this center about this vertical. Symmetry. Double click from this center to the horizontal. This is of value 100 and this is of radius 20. This is also of radius 20. Now distance between them is from this center to this center 80. We have constrained the two circles. Now exit. Go to Insert, Sketch-based features, Multi-pad. Select on this sketch. To this circle, we'll give a value of 40. Again, I'll take this circle and give a value of 30. Click on OK. So by using one sketch, we have created both the pads. Now again, I'll take sketch, this plane on which we had created the circle. create a rectangle. This line with this circle, tangency. Again, this line and this circle, tangency. Now, this line and this line about vertical will use symmetry. I'll take dimension between these two lines is 80. Exit Workbench. Use pad and give a pad value of 10. Click on preview and OK. Now again we'll take the same plane. I'll take rectangle. This line and this edge, coincidence. Now this line and this edge, coincidence. This line and this edge, coincidence. We'll take normal view. Now we have to give this thickness, which is of 10. Exit Workbench and use pad to a value of 30. Take preview, click on OK. Now we'll create some holes. Take hole on this face. We'll first position the sketch, that is position the hole, this hole and this circle. Concentricity. This point is actually representing a hole, so it has a circular feature. So that circle and this bigger circle, both will be concentric. Now we'll take a diameter of 20 and we'll give here up to last. It will cut everything and go. Click on OK. Very easily we have generated this hole. Similarly, again we'll take hole on this face. We'll take positioning, this point and this circle. Concentricity. It's not between the point and the circle. It is between the hole and the circle. So both can be concentric. You can give concentricity. Exit Workbench. Give a value 20 dia and we can take here up to last. Click on OK. You can see the hole has been generated. Now we'll take sketch and we'll take this plane. We'll make a rectangle. Now we'll take this line and this edge and give coincidence. We'll take this line and this line about the vertical. Symmetry. And as we have taken the center of this circle 100 from this horizontal, so directly we can select this line and this horizontal axis and give a coincidence constraint, so that directly from this edge to this center it becomes 100 length. Now I'll take dimensioning between these two lines. This value is 60. We'll take fillet, double click on fillet. Double click. Radius 10 mm. This is also of radius 10. Now we'll directly take this elongated hole in this sketch itself. I'll take profile, predefined profile, elongated hole. Click here and create a elongated hole. This radius value is 10. Double click on dimensioning from this spine to this line. This is 30. This center point to this line is a value 20. This total length is 15. Now exit Workbench. We'll take pad, give a value of 10 mm. You can see. Now click on OK to create the solid model. So this is the solid model that we wanted to make. In this video, we are going to see a tool called Edge Fillet. You can see there is an object here which I have created by creating a sketch, which is this face, and using pad to make the solid. On these edges, we want to create fillets. Let us see what is a fillet. I'll go to Insert. We'll go to Dress Up Features. If you have a sketch, you can create a feature in sketch-based features. And if you have a feature, you can use this Dress Up Features for editing their geometries. Let us take this first one, Edge Fillet. Click on any edge and give a value, maybe some 10 mm. Click on OK. And you can see this is a fillet. It's a rounded corner. Again, let us create a fillet. I'll go to Insert, Dress Up Features, Edge Fillet. You can click here or you have the toolbar here. This is the Dress Up Features toolbar. Click on this Edge Blend. Select the edge. Click on Preview and OK. Very easily we are forming these rounded corners. This is called Edge Blend. You can also create a blend by taking multiple edges. Let us select Edge Blend again. When I click on this edge, you can see directly the tangential edges are getting selected. It is due to this selection mode. Now when I click on OK, you can see it is blending. This is called Edge Fillet. In this lecture, we are going to see how to create a chamfer by using the chamfer tool in Catia. As you can see here, I have a solid here. I have created it by using a sketch containing these edges and using pad to make the solid. Now I'll go to Insert, Dress Up Features, Chamfer. Select any edge, give a value. Maybe I'll give 10 mm. Click on OK. You can see this is a chamfer. Now let us take chamfer again. You can go to Insert, Dress Up Features, Chamfer, or you can also click on this icon here. There are two methods, length angle and length length. In length angle, you can give the length and you can also give the angle. Suppose let me give 10 mm and I'll give an angle of 60 degrees. Click the edge on which you want to create the chamfer. You can see. You can also reverse the direction if you want to change the direction of the angle. Click on Preview. You can see it is forming something like this. If you reverse the direction, it will orient the 60 degrees. So, click on OK and you can create a chamfer. I'll click on chamfer again. We'll go for length. You can give different lengths to the two sides of the chamfer. Suppose I'll give 5 mm here and 10 mm here. Select the edge. Click on Preview. You can see This is 5 mm and this is 10 mm. If you want to reverse, you can do it. Preview. Now this top portion is 5 mm and this is 10 mm. So it depends on you. Click on OK and we can create chamfer. You can see this is the chamfer tool for creating chamfers on solid edges directly. In this lecture, we are going to create the 3D model of example 26 drawing attached in this lecture. You can see here, this is the drawing for which we are going to generate the 3D model, and this is the 3D model that we want to make. You can see the fillets and chamfers being applied to the body. Always apply fillets and chamfers at the end of the modeling, so that it doesn't create any complexities. Let us start by first creating a sketch. On this plane, we will create a circle. Give the diameter as 40. Click on OK. Now exit Workbench. Let us use pad and give a length of 100. Click on OK. Again we'll take a sketch on this face. We'll take an elongated hole. From this point, you can use this isometric view to generate the perfect sketch to define our object. You can see. Now I can take plane normal. Now double click on this dimension. This is 25. Now I will take dimension of this spine. This is of value 50. The sketch is constrained. Now we'll take exit Workbench. We'll use pad. We'll reverse the direction and give a value of 20 as the pad dimension. Click on OK. You can see we have formed our pad and the outline of our model. Now we'll create the interior objects, which are holes. I'll click on hole, select this face. I can move the hole somewhere here. Now we'll go for positioning sketch. This point and this arc. Concentric. Click on OK. Exit Workbench. We'll create a blind hole of diameter 30, which is of radius 15. Click on preview and click on OK. We have not given the depth. Double click. Here we'll go for up to last. We need not decide any depth. It will cut the entire object. Click on OK. You can see it has cut everything up to last. Now we'll take hole again. Click on this face. Now let us give a value. Before that, we'll change this type to counter bore. You can see a preview here. Select any object and you can see a preview here. The counter bore diameter is 32 and the counter bore depth is 10. Again we'll go here to extension. The hole diameter is 20. Click on preview. You can see this is the preview of the object. Click on OK. And we have made the counter bore. Now we are left out with the last portion, that is the fillets and chamfers. Let us first give the fillet. Click on edge fillet. Select on the edges where you want to give the fillet. We'll select this edge, this complete edge, and this complete edge with a value of 5. Click on OK. You can see very beautifully it has blended and created the fillet. Now we'll go for the chamfers. Click on chamfer A chamfer of 2 into 45 degrees is given. It is typical that indicates any chamfer values wherever it is of 2 into 45 degrees. So as it is length and angle, we'll give 2 here and 45 degrees. Now let us select the objects, that is the edges. We'll select this edge. By mistake we have selected the face, so we can deselect by pressing the Ctrl button and selecting on the object that you want to deselect. We'll select this edge only. Now we'll select this edge, and we'll select both of these edges, this edge and this edge. Click on OK, and you can see we have created the chamfers. We have completed the 3D model. Click on isometric view, and you can see here. This is the model that we wanted to make. In this video, we are going to create the 3D model of example 27 drawing attached in this lecture. You can see here, this is the drawing for which we are going to generate the 3D model. And this is the 3D model that we are going to make in this video. Let us start by creating a sketch on this plane. I'll create an elongated hole. Click here, and before you create the spine, let's see the drawing. I want to make the 3D model something like this. So when I click the isometric view, it should come something like this. So my base that I'm going to create, which is this plate, should be aligned in this direction. For that, I'll take isometric view. You can see, now I'm in 3D. I'm working on 2D plane, but I'm in 3D. I can create the spine in 3D. So that I'll create the base sketch oriented as I like. If I click on normal view, the orientation will be something different. You can see, double click here. This is of 25 and this spine length is 80. Now click on Exit Workbench. Click on Pad. We'll give a value of 15. Click on OK. Now we'll take Sketch on the center plane. Click on Circle, maybe somewhere here. Now the distance from this point to this axis is 80 divided by 2. Which is 40. Again, I'll take dimensioning of this center from this edge. This value is 35. I'll take dimensioning again and give a radius to this circle of 20. The circle is constrained. Now we'll add the lines. Select on Profile and create a profile something like this, a set of horizontal and vertical lines. Now I'll take this line and this circle, tangency. Now select this line and this circle, tangency. This line and this edge, coincident. Double click on Quick Trim, trim this object, this and this, which are not required. Now exit Workbench. You can see the sketch is exactly in the middle. We'll use Pad, reverse direction. Click on More. We'll give the first limit and the second limit. The first limit is 25, that is up to this edge. and the second limit will start from -15. So this thickness will be 10 mm. So from this sketch plane to this plane, it is 15. So as it is on the other side, so we will give second limit as -15. And from here to here, it is 10 mm thickness. So this face is 25. Click on preview. It's okay. So click on OK. Now again we'll bring back that sketch. I can click on swap visible space to get into the other visible space where we have the hidden objects placed. Click on hide or show and select this sketch. Again I'll click on swap visible space. Now I'll take pad, select this sketch. Same as earlier, we'll click on more. The finishing is at 25 and the starting is -15. You can see a preview. Now click on OK. Now only we are left out with the holes. Click on hole on this face, positioning the center of the hole with this circle. We'll click and create a concentricity. Exit Workbench. The diameter of the hole is 20 and we will create a through hole. So we'll click here up to last. Click on OK. Now similarly, we'll take hole again on this face, positioning sketch, the center of the hole with this arc. We'll create a concentricity constraint. Exit Workbench, 20 diameter up to last. Click on OK. Similarly, I'll take hole again on this face. The diameter is 20. Let us take positioning. Now select this arc and the center of the hole. Click on concentricity. Click on OK. Exit Workbench up to last. Click on OK. You can see we have formed a 3D model. In this lecture, we are going to create the 3D model of example 28 drawing attached with this lecture. As you can see here, this is the drawing for which we are going to make the 3D model. This is the 3D model that we are going to make in this video. Let us start by creating a sketch. On this plane, we'll create a circle. Maybe we'll take this origin and create a circle. Give a radius of 30. The circle is constrained. Now exit. We'll use pad and we'll use mirror extend and give a length of 100 divided by 2, 50 per side. Let us see the drawing again. You can see here, this total is 100. That is 50 and 50. So our plane is this plane on which we have created the first circle. So all the objects we can create in this plane and extrude on the front side so that we will get this geometry. I'll take sketch, the same plane, create another circle somewhere here. We'll position it. I'll take dimensioning from this center to this horizontal. This is of 80. Again from this vertical axis to this point, double click. This is of 80. Now select this circle. We'll give a radius of 50 and it is constrained. Now finish the sketch. We'll use pad and give a length of 30. Click on OK. You can see the position is very important. Now we'll take the same plane, and create the tangents. Click on Profile. Create 4 lines. This line and this circle. Tangency. This point and this circle. Coincidence. Click on OK. This and this. Tangency. Again, this point and this circle. Coincidence. The similar constraint will apply here. I use this point and this circle. Coincidence. And this circle again. Tangency. Here also we'll take point and this circle. Coincidence. Tangency. Now exit Workbench. Click on Pad. The thickness of this profile is 10. So click on OK. And you can see we have formed the structure. Now I'll take sketch on this plane. Click on elongated hole. The spine will be straight, vertical. Click somewhere to create an elongated hole. Now I'll take this circle and this circle. Concentric. Now I'll just give this dimension, which is 30. Forget about this. It doesn't matter because we are just going to cut it. Click on Pocket. And here we'll take up to last. It will cut everything. Click on OK. You can see. Try to draw the figure as simple as possible. Now I'll click on hole on this face. We'll take positioning sketch, this hole and this circle. Concentric. Exit. We'll take a through hole that is up to last with a diameter of 30, that is radius 15. Click on OK. And you can see we have formed our model. In this lecture, we are going to see two very important tools, shaft and groove. These tools are used for creating rotating elements. You can see I am in the part design interface of a new file. I'll create a sketch. Click on the sketcher icon. Click on this plane. Let us make a profile, something like this. Let it be something like this. Exit Workbench. Go to Insert, Sketch Based Features, Shaft and Groove. These two we are going to see. First, we'll see shaft. Click on shaft. Select the sketch. Select the axis about which something will occur. We'll see what is that. Here I'll give a degree of 270 so that we can see what happens, and click on preview. You can see something is happening. This cross section has rotated about this axis and created a solid of 270 degrees starting from here. So 0 to 270 degrees. You can see here. From 0 to 270 degrees, it has taken and created a solid. This is a very important option. If you have a section and it has to be revolved about an axis. Here, this is axis. Click here. You can change the axis wherever you want. I have taken this datum axis. If you want, you can take any edge or any other axis. You can see I have taken its own edge. Let us again take this V. Always click here and select an axis. Click on preview. This is the start angle and end angle. You can give a value of 360 degrees to get a complete rotation. You can see it has completely rotated. Again, let us keep here 270 degrees. Here I'll use thick profile. You can see. Here I'll give a thickness value maybe of 2 mm. Click on preview. You can see here it is creating a hollow body. It is having a thickness of 2 mm. So from the cross section it gives a value of 2 mm inside, and if you want it outside also you can give a value maybe 4 mm. See, click on preview. So outside 4 mm and inside 2 mm. So if you are having a thickness from the cross section which you have to give inside and outside, you can use these values. Or you can take, what it will do is it will keep the sketch in the center and give a thickness on both the sides. Suppose I'll give some 4 mm. Click on preview. The total thickness is 4 mm. You can see here this total thickness is 4 mm. Click on OK and see. A very beautiful body has been generated very easily. Now double click on this and I'll remove this thick profile. Click on OK. I'll select this plane, go to Sketcher and maybe take a rectangle. This time I'll use groove. This is shaft and this is groove. Click on this cross section. It's the same window that you will get in shaft, and axis I can select this cylinder or I can direct select this axis. It's your wish. Click on preview. We are not able to see clearly, so I'll click on OK. Now you can see it has removed the material. It works on the same theory as shaft, but this time it removes material. So shaft is for adding material about an axis and groove is for removing material about an axis. So in groove, the cross section, which is the rectangle, has revolved about this axis that we have selected, and while doing so it has removed the material from this base body. Now double click on this groove again. Here we have a thick profile option like we had in the shaft. I'll give a value of 2 mm and this I'll make it 0. Click on preview and click on OK so that we can see clearly. You can see what has happened. It has not removed the entire material. It has removed only 2 mm material that we have given in the thickness value. Double click here. You can see this 2 mm has been given inside and the material has been removed while revolving. The material in the center is left out. So if you want a case where you have some grooves, something like this, then you can use this option. We will see the application of shaft and groove in the further examples. For now, this is the concept of shaft and groove. In this video, we are going to create the 3D model of example 29 drawing attached with this lecture. You can see here, this is the example 29 drawing and we are going to create this 3D model. Let us start by first selecting a plane. I'll select this plane and creating a sketch. Click on sketch. Let us create a rough profile. I'll click on profile. I'll start here a vertical line, a horizontal line. You have to just create a boundary. While doing so, you have to prevent the unnecessary constraints. These are unnecessary constraints, you can see. So you have to prevent and make the sketch. And I will join here. Now select this line and this vertical axis. Coincidence. Double click. Let us give a dimension from here to here. This dimension is 24 divided by 2. 12 is the radius. Similarly from here to here. Double click. This is 34 divided by 2. 17. Again from here to here. This length is 34. From this point to this point, this length is 60. From this point to this horizontal axis, this radius is 80 divided by 2. From here to this line, this angle is 15 degrees. And from this line to this vertical, this is 70 degrees. This line length is 20. This length is 10. From this line to the axis, this radius is 65 divided by 2. Now from here to here, this dimension is 80 divided by 2, but already we have given 80 divided by 2 to this point, which is not correct. So you may face problem something like this. Sometimes I will delete this dimension, just double click this dimension and give a value. This is actually 54 divided by 2. You can see. Now double click again on dimensioning from here to here. This is 80 divided by 2, which is 40. From here to this horizontal axis, this value is 100 divided by 2, 50. Now suppose we are not sure which constraint is actually left out. Just hold any line and move. You can see it is moving the horizontal axis. The complete set is moving the horizontal axis. That means it doesn't have a fixed value with respect to the horizontal. Now let us check it out in the drawing. This portion is moving. So you have to give a horizontal value with respect to any constrained geometry. If you see here, this is a 30 value with respect to this end. So this dimension we have not given. Click on dimensioning from here to here. You can see it is completely constrained now and we'll give a dimension of 30. Now just finish the sketch. Very simple option. Shaft. Select on this sketch. Now select the axis. As we have given the radius value with respect to this horizontal, So this horizontal will be the center of the body. So about that center we will rotate. Click on OK. Very easily we have formed the solid. But it is not 360 degrees. We will give a value of 270 degrees. Let us see a preview. It is actually on the other side, so reverse direction. Preview. This is exactly what we want. Click on OK. And here we can click on isometric view to get an isometric view of our model. So this is the 3D model that we wanted to create by using the soft tool. In this video, we are going to create the 3D model of example 30 drawing attached with this lecture. You can see here, this is the drawing for which we are going to generate the 3D model, and this is the 3D model that we are going to create. We are going to use a combination of soft and groove tools. Also, you have to see how the sketches are being made. This is a very simple solid geometry, but it is very important for understanding the soft and groove. Let us start. First, we will take this plane, click on sketch and create a rough sketch. Click on profile, I'll click on origin and make a sketch something like this. Click on the escape key to exit from the command. Now double click on dimensioning. This radius is 25 divided by 2. And from here to here, this radius is 32 divided by 2, 16. From this axis to this line, this is a value 50. And from here to this axis, this is a value 80. Now let us select this entire sketch and we will click on mirror about this axis. You can see. Now exit Workbench. Click on soft tool. Select the section and in axis, I'll select this as the axis. Click on OK. You can see here we have created the body. Now we'll click on this isometric view. We will select this plane. Click on sketch. This time I'll just create a rectangle. This is a rectangle. Between this line and this axis, I'll give a constraint called coincidence. This line and this line about the horizontal, we can keep this symmetry, and the total line length is 50. Select on dimensioning. This radius value is 50 divided by 2, 25. Exit Workbench. Select on soft. Select the rectangle and the axis I'll select as its own line. You can see. Click on OK. Now we have to just cut the portion. For that, I'll select on sketch, select this plane, click on profile, and we will create a profile, something like this. Join here. Now I'll take this line and this axis, coincidence, this line and this coincidence. This line and this coincidence. Always drag and refigure the geometry so that you don't get confused. From here to here, this value is 10. From here to here, this radius is 32 divided by 2 and this radius is 40 divided by 2. Exit Workbench. Select on Groove. Select the section. Axis, I can select the axis of this cylinder. You can see the axis is highlighting. Select the cylinder. Just select on OK. And you can see here we have created the body. We have used a combination of shaft and groove to create the body. In this lecture, we are going to create the 3D model of example 31 drawing attached with this lecture. This is the drawing for which we want to create the 3D model, and this is the 3D model that we are going to make. Let us start. First, we'll create a sketch. I'll click on the sketch icon. We'll take this plane. We'll take profile and create a profile something like this. The view has rotated, so we'll click on normal view. Let us zoom in. Select this and this axis. Coincidence. Double click on dimensioning from here to here. This radius value is 24 divided by 2, 12. From this point to this vertical, this value is 50 divided by 2. From this point to this vertical, this is 74 divided by 2. Now the height. This total height is 45. So we are having now the sketch. We'll exit the workbench. Click on shaft. Select this section and select this vertical axis 360 degrees. Click on OK. Now again we'll select the sketch. We'll take the same plane. We will create two concentric circles. Double click on circle. Create a circle here, and again I'll take its center and create another circle. Press on the escape key to exit from the command. Now double click on dimensioning. From this axis to this center, this dimension value is 70. From this horizontal axis to this center, the location of this center is 35. Now we'll give the diameters. This inside diameter is 30 and outside diameter is 50. The sketch is fully constrained. Now exit workbench. We'll take pad, select this sketch and give a value. First we'll create a mirror extent, and this length will give a value of 60 divided by 2. So 30 per side. Both the bodies have been created. Now we have to create the intermediate body. Let us select the sketch. Again the same plane, and let us create a profile. We'll create a profile something like this. this line and this edge coincide. Double click on dimensioning. From this axis to this line, the value is 35. Deselect dimensioning and let us move it so that we'll get a perfect figure that we want. Double click on dimensioning. From this line to this axis, this is of value 22. From this line to this point, that is the length of this line. Double click, this value is 10. Double click on dimensioning again. From here to here, this angle is 15 degrees, and this thickness, this is 10 degrees. No need to constrain this line because it is going to merge with this cylinder, so it doesn't matter. Just keep it inside it so that there will be sufficient material for adding. Now I'll take pad, mirror extend, and this total thickness value is 20. So 20 divided by 2. We have created the middle portion. Now we have to just give the fillets. Let us click on edge fillet. We'll get it here. Edge fillet, or I can go to insert, dress of features, edge fillet. Click on this edge and give a value 6 mm. Click on OK. Now again we'll take edge fillet. Select this edge. Give a fillet value of 10. Click on OK. And you can see here we have made the 3D model. In this video, we are going to see how to create threads on solid bodies. You can see here, I have created a block. On that, I have created a cylinder and I have created a hole, which is through. On this hole, I'll create an internal thread, and on this cylinder, we will create an external thread. Let us see. We'll go to insert, dress of features, thread. We have thread and tab. Thread is for external threads and tab is for internal threads. Let us first select this lateral face, which is the face on which you are going to create the thread. Let us select this face first. After you select the face, you can get a preview here. Tab is for internal thread, thread is for external thread. Next is the limit face. That is the face from which your thread will start. My thread will start from this face. The type is dimension. That is, we have to give dimension up to which you want to get the thread. Here the type is standard. That is, what type of thread you want to create. Metric thin pitch or thick pitch. Here by default we have the thin pitch and thick pitch. Let us take thick pitch. This cylinder is having a diameter of 20. So directly it is taking a thread of 20. You can see it's 20 up to depth of 50 and the pitch is 2.5. You can create a right hand or left hand thread. It's your wish. Click on OK. We cannot see any thread on this solid. But if you go to navigator, you can see a thread has been applied on this solid. When you click on this thread again, you can see up to what depth you have created thread and all the parameters you can see it here. You can change the values if you want. Now cancel this. So in Catia, you cannot see a thread directly on the solid. You have to see it in the part navigator. This is for increasing the performance of Catia. As Catia is a very heavy software, it gives a lot of load on the graphical unit of the CPU. So to make the things faster, here we are not able to see it visually, but it is there in the part navigator. And later on when we use drafting, you can see that this thread will directly reflect in your drawings. So this is the external thread. Now I'll go to Insert, Dress of Features, Thread. This time we'll select this internal thread. This internal surface I have created by using a circle and using the pocket. That's why we are able to create the thread. But if you want to create a hole, then directly we have the thread option in the hole. That we'll see a bit later. Now the limiting face will take this top face. Now same as the thread option, in tab also we have the same metric thin pitch and thick pitch. Click on thick pitch. You can see here in surfaces something like this. You will have a problem creating this diameter. I have created a 20 mm diameter, but the value recommended for our M20 standard thread is 17.298. So we'll click on cancel. We'll double click on this. Click here. Double click on the diameter 17.298. Click on OK. Now we'll take thread again. Insert, Dress of Features, Thread. We'll take tab and we'll take this face. Limiting face is this. You can see here without any errors, directly the thread M20 has been taken. So you have to decide what the hole diameter should be to create the perfect thread. You can see here the support diameter is 17.298 for creating a M20 thread. The pitch is 2.5. These all are automatically given. Thread depth you have to give. It's your wish. I'll give some 30. You can create right or left hand. Click on OK. And similar to the external thread, this also you cannot view. You can see here. This is the thread that you can see in this part navigator. Now we'll go to hole. Click on hole. We'll place the hole on this face. Here we have this thread definition. Click on thread definition. Click on threaded hole. The type is dimension. Let it be dimension. Here you want to create thick pitch or thin pitch. Let us create a thick pitch. And here we will create a standard. Let us create a standard M20 hole with thread. Thread depth you can give maybe some 40. You can create right hand or left hand thread. Now just click on OK. And the thread has been developed along with the hole. So for making this internal threads in holes, the hole option is actually easier than the tab option. So it's better to go for a threaded hole directly by using the hole command instead of going for tapping. So this is all about threads. In this video, we are going to see how to create planes. By default, you can see there are 3 planes in our graphics window, which are the XY plane, YZ plane and ZX plane. Apart from this, if you want to create some planes, then we can do it by using the reference elements. Let us create some more planes. But before that, let us find out where are the reference element icon. When I right click here, you can see these are the various toolbars that we can display. Here we have this reference elements extended. Already it is ticked. So we have that somewhere. We have to find out. You can see here, when I move, there are some toolbars hidden. This is the reference elements toolbar. I'll keep it here. This toolbar I can keep it somewhere here. And this modify toolbar I can keep it here. These are the reference elements. Point, lines and planes. Let us click on plane. The very first one is offset from plane. This is the first one that we are going to see. Select any plane, maybe this plane. You can see what happens is, at some distance another plane has been created. The distance you can give it here. See, I increase the distance and the plane also moves. When I click on repeat object after OK and click on OK, you can see it will ask how many offset planes you want to create. Let us create some 4. Here, create a new body, you have to deselect. In the later part of the course, we will see how to create a new body. Before that, you just uncheck this. Click on OK. You can see here 5 planes we have created. And these are all dependent upon this dimension. You can change this dimension and automatically the value of others will also change. Click on OK. You can see here. They are all associative. Now let us create a plane at an angle. Let us select plane again. Select any plane. Maybe I'll select this plane. Here, angle normal to plane. Click here. In rotation axis, as we don't have any lines or edges or any kind of linear features, so we cannot give this rotation axis by selecting here. But you can right click here and always you can give this datum axis. You can see here, this is the y axis, x axis and z axis. I'm going to give this y axis. Click on y axis. Let us give an angle. You can see here, an angle is given to that plane and a new plane has been created. The green one is our created plane and the orange is the datum plane that we have selected. Suppose I'll select here 45. Click on OK. And you can see a plane at an angle has been created. This is the plane. Now you can take this plane and click on creating planes again. We'll take offset from plane. You can also reverse the direction. You can see here a new plane has been created at 30 mm from our selected datum plane. Now when I click on OK, you can see here a new plane has been created. Also now let us take a solid. You can see the sketcher icon has been hidden. So let me close some of the toolbars and position the sketcher icon somewhere here. Click on sketch and maybe I'll select this plane. I'll create a rectangle and maybe I'll create a solid block. Now let me create a plane at an angle. I'll take plane, select this top face. You can see an offsetted plane is directly getting created from this top face of the solid. But I want to create an angle plane. Rotation axis, I can select any axis as we have lot of linear edges. Let me select this axis. You can see here at 45 degree with respect to this axis, a plane has been created and that you can use for any type of feature. I can select this plane, take sketch, maybe I'll create a circle and a pad maybe, reverse direction, click on OK. You can see. So you can create angular holes and any type of features which are at an angle with a object. So this is how we will create this offsetted planes and planes at an angle. We'll see the application part of this in the further videos. Also, in the later videos, we will see how the planes can be created in other methods. In this video, our objective was to see how to create offset planes and plane at an angle. In this video, we are going to see how to create project 3D elements, intersect 3D elements, and project 3D silhouette edges. Also, we are going to see an option called isolate. Let us start by first creating some solids. I'll take this plane, create a rectangle and a circle. Exit. I'll use pad and maybe create these two solids. Let us take a plane. And go into the sketcher. Maybe I'll take this plane. Now I'll take insert operation 3D geometry. This is a tool inside the sketch, but it will be used for solids. Project 3D elements. When you click on project 3D elements, what you can do is you can take the reference of the 3D in our plane. You can see this plane is active. That is, we are on